Hey there, everyone. Meteorologist Ryan Weekman here live. You're joining in for the first edition of our Weather Hangout Kids Edition. Glad you're with us here. We've got over 100 students joining us right now, and we're going to be talking about thunderstorms for today. Now, many times when we do these live streams, we've got a live chat that allows you to kind of ask questions or type on in here. I'm looking for it, but I don't see it popping up this time, so you might not be able to ask questions for this round, but we're gonna try and fix it for the next one. Super glad that you guys are joining us. Again, this is our Weather Hangout Kids Edition. And we miss you guys. We usually come on out to the schools this time of the year. Kindergarten, first, second, third, fourth, fifth grade, even the older kids. Obviously, with everything that's going on, we're not able to do that. And you can see, typically, I would be reporting live from the First Alert Weather Center, right? But I'm home right now, and we thought it was still important, though, to give some educational opportunities. So we wanted to give you a chance to come on in. We're going to learn about thunderstorms. If you're an older kid, stick tight. We're going to kind of start this off at a basic level about thunderstorms, and we're going to work up from there. So you're going to have a lot of fun. You're going to learn something, I promise. If you can't hang out long, and parents, if you're watching here, look in the comment section below or in the description section below, and you're going to find all sorts of interactive activities that we've kind of lined out for you to do. It's for kids as young as preschool, kindergarten. There's some coloring pages that you're going to be able to print off if you look at that. There's a maze down there as well. For older kids, I've included some links to the National Weather Service where there's interactive games so you can learn about thunderstorms as well. So again, we're really excited about this. This is our Weather Hangout Kids Edition. Now, we do Weather Hangouts all the time, but this one's just for you students, okay? So I'm going to try and bring this up. Hope that the stream looks just fine. I'm trying to, hold on one second. See if the comment section is working, because usually we have that up. I want to be able for you guys to be able to ask questions, and if that doesn't work this time, that's okay. We'll fix it for next time. But if we're able to, I would like for it to work this time so I can see where you guys are coming from, because I know we've got kids from all across Northwest Ohio and Southeastern Michigan that are joining us here live on this Weather Hangout. So when we talk about what we're looking forward to, thunderstorms. Okay, how is a thunderstorm made? This is one of my favorite things to do when I go to a classroom is, first of all, I ask, which one comes first? And you can answer this question right where you're sitting right now. Which one comes first? Thunder or lightning? When a storm is approaching, which one comes first? Thunder or lightning? Now you might say to yourself, well, thunder, that's the sound we hear, right? You're right, we hear thunder first, but lightning is actually what makes thunder. So you can't have thunder without lightning. Does that sound a little confusing? It's a little strange, right? All right, let's go back to the basics. Let's talk about this a little bit more. If you, let's say the other night, were you woken up or did you stay up late enough? Did you get to see the thunderstorms that came through? Let's start with this. What did the lightning look like? Was it bright? Was it dark? Yeah, lightning can be pretty bright, right? And it comes with that loud sound. That's the thunder that we hear, right? Well, it's kind of like smoke and fire. Can't have smoke if you don't have fire, right? Well, you can't have thunder if you don't have lightning. So how does that exactly work? How do we get lightning? Here, let's show you a picture so we can talk about thunderstorms and what exactly is going on in thunderstorms. That's a pretty cool picture, isn't it? Yeah, I thought it was pretty neat, so we put it on here just to show you a little bit more of a description of what's going on with thunderstorms. Okay, so I asked you the question, which one comes first, thunder or lightning? Well, the answer is lightning, and here's the reason why. Lightning makes the thunder. Here, I'm going to have you make your own thunderstorm, okay? Here's what I want you to do. All right, so you're sitting there, right? Looking at the screen. Okay, you're going to make your own thunderstorm. Here's what I want you to do. We're going to start rubbing our hands together. Have you maybe done this in school before? It's called static electricity. That's what we're building up inside of these thunderstorms. It's kind of like, and maybe you could do this later with your parents, blow up a balloon and rub it on your head. What's going to happen? Do you know? What's going to happen? If you rub that balloon on your hair, what's going to happen to your hair? Right? It's going to come on out, right? That's static electricity. It's the same thing as if you were to walk across the carpet, go up to turn the light switch on, Does it ever shock you? That's the same thing because your feet were rubbing on the carpet. So it's called static electricity. Okay, you're going to do this with me. Are you ready? Right there. I can see you guys out there, okay? Are you ready? You're going to help me make a thunderstorm, and you're going to understand how it's made, okay? Here's what I want you to do. I want you to take one hand. Don't be shy. I see you sitting out there. Don't be shy. Reach one hand up into the air, and you're going to grab into the cloud. This is our rain. Okay, we're reaching up into a cloud. We're pretending here. We're reaching up into the cloud. We're grabbing rain with this hand, okay? Now with this hand, I want you to reach up into the cloud. And I want you to grab hail or ice that's way up in the clouds. It's cold up there, so there's some ice that's up there too, okay? So we've got our, what is in this hand? Do you remember? What's in this hand? Rain. Good job. And then what's in this hand? Hail or ice. Yep, exactly right. Okay, so we're going to take this and we're going to rub them together because what's going on in a thunderstorm is some of the rain is falling down, some of the ice is coming up, but they're rubbing together while they're up there in that thunderstorm, and that builds up the static charge, okay? Just like when we rub that balloon on our head, whoop, the static charge, well, that static charge gets built up. Okay, you ready to make your own thunderstorm? You paying attention? Okay, you got your hands above your head like this. We're rubbing them together. Okay, now let's make that lightning bolt. Are you ready? Okay, down comes the lightning bolt. Yep, just like this. Okay, you can make it look however you want. So this is your lightning bolt. Now here's the really cool thing about this. Lightning moves so fast through the air, it actually rips the air apart. Kind of. It's close enough, okay? Watch. It goes like this. Go. All right, you want to do that? Okay, make the sound with me. Put your hands back together. Okay, make your lightning bolt. Coming on down. Now, it rips the air apart, goes, yep, just like that. Okay, now let's keep our lightning bolt going down to the ground, and when it hits the ground, it goes boom. So our lightning bolt made, what's that sound? Sounds just like thunder, doesn't it? Yeah, just like a clap of thunder. So our lightning bolt came down, boom, and it made thunder. Let's do it again. Okay, we're all going to do it together. So I want everybody to clap so loud we can all hear each other. Okay, you ready? Reach your hands way up high. What's this hand? This one's the hail, the ice, or the rain. You can make it whatever that you want. The other one is the hail, or the ice, or the rain. Okay, what are they doing up there? Yep, they're rubbing together. Okay, now let's make our lightning bolt coming out of the clouds. Good job. And what happens? It rips the air apart. Yep, just like that. Creates a vacuum in our atmosphere. Really small. Keeps going down, keeps going down. When it hits the ground, it goes. Yep, just like that. So our lightning makes thunder. Is that pretty cool? I think that's pretty neat. I am fascinated with thunderstorms. I hope you are as well. Obviously, you're at least paying attention and trying to move along with some of our experiments. So let me ask this question. I'll put our picture back up here because I think it's a pretty neat picture. How wide is lightning? That's the question I want to ask you guys first. I'm going to put this up here. There's another picture. Pretty cool, right? How wide is lightning? Can you answer that? Not how tall it is. We know it's super tall, right? It goes from the clouds all the way to the ground sometimes. But how wide is lightning? That's what I want to know. Can anybody take a guess? Any ideas out there? Again, next time, I'm going to try and get the comment section to run so I can read your comments in real time. Usually we can do that. I'm not sure why it's not set up this time. Let me see if I can get it working. Nope, there's no comments on this one, so I can't get it up and running. But I'm going to let you guys try to answer this one for yourself. How wide do you think lightning is? Do you think it's like off the screen big, like, whoa, super big? Do you think it's like tiny, like this? Show me. Hold your hand up. What do you think? Is it like that, like this, like this, like this, like this? Whoa, can I reach my hands out? Look at that lightning bolt right there. Here, I'm going to show you the answer. This is kind of a crazy answer. Now, lightning can come in different shapes, sizes, and widths, but sometimes lightning can be as thin, I'm going to try and hold this up, as the thin side, the edge of a sheet of paper. Now, wait a second, Mr. Weatherman on here on YouTube. You're doing this weather hangout here, and you're talking about thunderstorms, and that clapping your hands thing was really cool. But hold on. How in the world lightning, that can be so dangerous, that can be so bright, the edge of a sheet of paper? Really? That's it? Sometimes it can be a few inches wide, but many times it can be as thin as the edge of a sheet of paper. Now, how is that possible? Do you guys know? Do you have any guesses? How is it possible that we can have thunder or lightning that is so dangerous, but yet it's only as wide as the edge of a sheet of paper? Well, the reason is because of how hot lightning is. That charge is so extreme and it happens so quickly that our eyes simply can't adjust. Remember, lightning oftentimes is many times hotter than the surface of the sun. Yeah, you heard that right. And so it's the same thing. Have you ever been asleep in the morning? You just don't want to get out of bed. I get it. But maybe your parents or somebody comes into the room, flips the light switch on, and it hurts your eyes. That ever happened to you before? Yeah, it's happened to everybody. It's because your eyes can't adjust fast enough that it hurts. Well, same thing kind of happens with lightning. It is so hot, it is so bright, and it happens so fast that our eyes can't adjust to how wide that it really is. It looks bigger than it really is. Of course, lightning is something we've got to be really careful with. For you younger kids that haven't learned this a lot in school just yet, we of course have to be super careful with lightning, and it's always time to go inside when a thunderstorm comes on by. All right, let's talk about this. I'm going to ask you guys another question. This one's maybe a little bit for the older kids. Let me see what else I've got in here. Okay. How big is a thunderstorm? You guys have any idea how big a thunderstorm is? Now, when you look up at the sky, right, it's really dark up there. We know it's pretty big, kind of goes across the sky, right? But how big is a thunderstorm? Well, very last minute addition here. I actually got a whiteboard. And so I want to draw this for you. And again, this might be a little bit better for the older kids out there, but I think everybody's going to learn something from this. So let's pretend this is our sky, right? We're down here. This is going to be you guys. Ready? Okay. That's you guys. Does that look like you? Should I draw some hair on there for you? All right. Little smiley face. You guys smiling out there? Come on, let me see some smiles. Yeah, there you go. All right. There's you guys. Now hold on. This is going to be me. I ate my vegetables when I was a kid. So I'm a little bit, there we go. I'm a little bit taller, okay? I'm a little bit taller than you guys. All right, but let's pretend we're out storm chasing or something, right? We wanted to look at a thunderstorm and get a really cool view of it. Well, let's draw a thunderstorm, right? Made out of clouds. There they are. So there's our big thunderstorm, right? Well, just to give you an idea how wide a thunderstorm can be, it can be as wide as maybe an entire county. If you live in Toledo, that's Lucas County. If you live in Wood County, that could be all the way from Perrysburg to Signet. In Lucas County, that'd be all the way from Lake Erie to Swanton. That's how wide these thunderstorms can be, and sometimes they're even bigger than that. All right, but how tall is a thunderstorm? This is not drawn to scale because I promise you we are not this tall. Well, this is a really cool thing right here. Let's see. Here's an airplane. Yep, there's an airplane flying in the sky. Okay, so we've got an airplane flying in the sky, right? An airplane typically flies when it's up there just kind of cruising around at around 30,000 feet. So there's your airplane at 30,000 feet. Well, thunderstorms, when they get strong or severe, can sometimes be as tall as around 60,000 feet. Now, do you think it's a good idea, if you were the pilot on this plane, do you think it'd be a good idea for you to fly your plane right into that? No, you don't think so? Or yes? Okay, what would be so dangerous about going through a storm? If there's an airport over here and I want to land, well, can I just go whoop right through the storm? Why would that be not a great idea to go through a big thunderstorm? Well, maybe you've listed a couple ideas. Here's one. Hail, those ice balls. Maybe you got some the other night when we had thunderstorms coming through. Airplanes do not do well in hail. That would not be good for the airplane. Let's see. Winds. Yeah, winds wouldn't be good, right? We always need the wind going the right way over an airplane. If the wind shifts inside this thunderstorm the wrong direction, that wouldn't be very good either. And even if it wasn't that extreme, even if it wasn't a dangerous situation, pilots like to avoid thunderstorms because oftentimes there's a lot of air that's rushing upwards. And so that can make for an unpleasant flight. You ever been on an airplane ride before and it's a little bit bumpy? Well, if you've ever been through a thunderstorm in an airplane, you know it is super duper bumpy. So that's something that, of course, you want to avoid. Okay, I've got another question that came in here. So I'm going to shift my view again. All right, here's a question for you. Could we have a thunderstorm with no rain? This seems kind of tricky, right? Could we have a thunderstorm with no rain? Is that possible? Well, around here in northwest Ohio, southeastern Michigan, the answer is not really. We're always going to have enough moisture in the atmosphere to have rain. But there are parts of the world where they get thunderstorms with no rain. And that's why places like California and other parts of the world, that's why they get so many wildfires, because the mountains help create thunderstorms and the rain evaporates before it reaches the ground. It's just too dry where it is. But it can still make lightning. That lightning maybe strikes a tree, and then you get a wildfire that happens. So kind of an interesting way to look at it. I've got one more graphic that I want to show on here real quick for you inside of a thunderstorm, just because this is a little bit of what we were talking about. And again, this is for the older kids that are out there watching. This is like a three-dimensional slice through a thunderstorm of what's going on. So you've got basically a living, breathing animal here, where the red arrows is the air that's lifting upwards, just like if you've ever opened an oven before, you know that rush of warm air that comes up? Well, same thing happens in a thunderstorm. Warm air rises. Vice versa. You ever opened up a freezer? Well, the freezers are so different nowadays. But when I was a kid, the freezers were always on the top, right? The freezers were always on the top, and you opened it up, and you got the cold air that kind of spilled it down. Same thing happens here in a thunderstorm. You open up the freezer, you open up the thunderstorm, cold air comes spilling out. That's why if you've ever experienced a thunderstorm, felt a thunderstorm, and you notice right before it hits or when it starts to rain, it feels a lot cooler, doesn't it? Yeah, so there's a big difference in different parts of these storms, and well, that's something that we watch, of course, very carefully when we're looking at kind of how storms work. Of course, we ask you guys, please be super smart when you're out there inside thunderstorms. Don't be outside. Here's a good question for you. If you're outside and there's a thunderstorm, let's say, is a car a safe place to be? Let's say it's not a really, really, really big thunderstorm, but it's pretty dark. It's got heavy rain with it and some thunder and lightning. Do you think going to a car would be a safe place? Well, the answer is most likely yes. A car acts like, for you older kids, look this up, it's called a Faraday cage. So lightning or electricity would strike the top of the vehicle, it would go around and then out through the tires. That's not to say that rubber shoes or rubber tires necessarily protect you from lightning. That's just to say that's the way electricity would flow through a metal vehicle like that. So don't think, there's a myth that's always out there that if you're wearing rubber shoes or something that you somehow would be protected. All right. I really, really wish that I had questions turned on here. I'm not really sure why in the comment section I'm not able to get you guys to be able to ask questions. I'm going to try and fix that for next time, okay? We've got plenty more of these topics that we're going to do. These are our First Alert Weather Hangouts Kids Edition. We're going to try and keep them to about 20 minutes, so parents and teachers, if you're out there watching, that's kind of how you can plan this. I get attention spans, okay? But again, look at the description below. We've got mazes, coloring books that are all free to download, print off, and there's games that older kids can play as well. You can make your own thunderstorms, and if you're a super weather geek like me, just a little bit younger, go all the way to the bottom section on there. There's an even bigger section. If you really, really want to learn about thunderstorms, it comes straight from some of the top scientists on the National Weather Service. So again, you will be able to watch it and learn and maybe potentially be a meteorologist of your own. So thank you guys very much for joining me. Again, this was our first Weather Hangout Kids Edition, and I'm so glad that you were able to join me. I promise next time we're going to look into the question issue so we can try to make this a little bit more interactive. You guys can ask your questions, and I can give a shout out to your classrooms as well. So thank you very much for being there. Really appreciate it, and we're going to see you around next time. Take care. Bye, guys. Keep learning, and be good to your parents, all right?